generating investment. The generative gold rush is on. Venture capitalists are betting hundreds of millions of dollars on startups that use AI to generate images, text, and more, Wired reported. A handful of generative AI startups have newly received nine-figure investments. They're among over 140 nascent companies that aim to capitalize on applications in copywriting, coding, gaming, graphic design, and medicine, according to a growing list maintained by Stanford student David Song. Stability AI, the London-based company behind the open-source text-to-image generator Stable Diffusion, raised over $100 million in a seed round that valued the firm at $1 billion. It plans to use the funds to develop infrastructure for Dream Studio, a commercial version of its text-to-image model, and triple the size of its workforce, which currently numbers around 100. Jasper, which caters to the content creation market, raised a $125 million Series A round. It offers a Chrome browser extension based on OpenAI's GPT-3 language model that generates copywriting suggestions ranging from a single word to an entire article. The company boasts over 70,000 paying users. Microsoft is poised to inject further capital into OpenAI, having invested $1 billion in 2019. Google reportedly is considering a $200 million investment into natural language processing startup Cohere. Established companies, too, are looking for ways to capitalize on AI's emerging generative capabilities. Microsoft is adding DALL-E 2 to its invitation-only Azure OpenAI service, which also includes GPT-3. It's also integrating the image generator into Designer, an app that automates graphic design for social media and other uses. Shutterstock, which distributes stock images, will allow users to generate custom images using DALL-E 2. The company also plans to compensate creators whose work was used to train their service. Getty Images, which competes with Shutterstock, is adding AI-powered image editing tools from Bria, an Israeli startup. In September, it banned images that are wholly AI-generated. Pushing voters' buttons as the United States, along with several other countries, gears up for general elections, AI is helping campaigns attract voters with increasing sophistication. Consulting firms typically combine publicly available data, which might include voters' names, ages, addresses, ethnicities, and political party affiliations, with commercially available personal data, such as net worths, household sizes, home values, donation histories, and interests. Then they survey representative voters and build models that match demographic characteristics with opinions on wedge issues such as climate change and COVID-19 restrictions. Haster QDNA scores 200 million voters on over 120 politically charged positions. The company helped U.S. President Barack Obama during his successful 2008 campaign. I-360 scores individuals on their likelihood to support specific laws such as gun control, increasing the minimum wage, and outlawing abortion. AI plays an increasing role in political campaigns worldwide. Both major candidates in South Korea's presidential election earlier this year used AI-generated avatars designed to connect with voters. In 2020, a party leader in an Indian state election deepfaked videos of himself delivering the same message in a variety of local languages. Ukraine's Lost Harvest quantified neural networks are helping humanitarian observers measure the extent of war damage to Ukraine's grain crop. The authors started with a database of grain silos last updated in 2019. They used machine learning to find facilities missing from that survey or built since then. The authors used a YOLOV 5 object detector classifier that Yale researchers previously had trained to identify crop silos in images from Google Earth. They fine-tuned the model to identify other types of facilities, grain elevators, warehouses, and the like, in labeled images from commercial satellites. In tests, The model achieved 83.6% precision and 73.9% recall. They fed the model 1,787 satellite images of areas in Ukraine that were affected by the conflict, dated after February 24, the start of the current Russian invasion. The model identified 19 previously uncatalogued crop facilities. Having located the grain facilities, the authors evaluated damage manually. Among 344 facilities, they found that 75 had suffered damage. They estimate that the destruction has compromised 3.07 million tons of grain storage capacity, nearly 15% of Ukraine's total. Massively multilingual translation. Recent work showed that models for multilingual machine translation can increase the number of languages they translate by scraping the web for pairs of equivalent sentences in different languages. A new study radically expanded the language repertoire through training on untranslated web text. The authors scraped web text, classified the languages in it, and combined what was left with existing monolingual data. Separately, they used an established corpus of parallel data. Then they trained a transformer on the monolingual and parallel datasets. The authors trained a CLD3 vanilla neural network on an existing monolingual dataset to classify languages. The CLD3 classified 1,745 languages in the scraped text. The authors removed the languages that proved most difficult to classify. They combined the remainder with existing data to produce a monolingual corpus of 1,140 languages. They eliminated languages that the CLD3 had frequently confused with a different language. They removed sentences that the CLD3, or a more computationally expensive language classifier, had failed to classify either correctly or as a related dialect. They also discarded sentences in which fewer than 20% of the words were among the language's 800 most frequently used terms. Then they discarded languages for which the available text included fewer than 25,000 sentences. Finally, a team of native speakers designed criteria to remove sentences of closely related languages. They trained a transformer to fill in missing parts of sentences in the monolingual data. Simultaneously, they trained it to translate examples in an existing parallel dataset that comprised 25 billion sentence pairs in 102 languages. This enabled the transformer to render a rough English translation from any language in the corpora. Continuing to train the model on both monolingual and parallel data, the authors added parallel data formed by pairing monolingual text with translations generated by the model. In learning to translate noisy, model translated text into ground truth text, the model learned to handle faulty grammar and usage. It also learned to translate from clean to noisy text. This forced it to translate among various languages more consistently and helped to avoid drastic, possibly damaging model updates. Results: the authors compared their 1,000-language model with a version trained on 200 languages. Given a test set that comprised 38 languages, the 1,000-language model performed better on most of them, including those for which plenty of training data was available, which suggests that greater language diversity was beneficial. When translating all languages into English, the 1,000-language model outperformed the 200-language version by 2.5 CHRF points, a measure of overlap among groups of characters between generated and ground truth translations. Translating from English to other languages, the 1,000-language version outperformed its 200-language counterpart by an average of 5.3 CHRF points.